recorder. Hello there, ladies and gentlemen. My name is Roger Weitzel. Today is January 12th, 2020. We're doing the first video we've done in a while, and wow, I've gotten a few wrinkles since then. Anyway, I'm looking more like my dad every day. At this point, we're just going to do a sample exercise. So I'm planning to give this to the SAT students at the beginning of class to see how they do. And let's have a look at what we're doing with them. So let me share my screen. I'm going to share the sound. And here is our problem. So the first thing I want to do, however, is to copy this link. So I'm going to put that in the chat. So if you guys could double click on that, you can see what the plan is for today. Let me go back to the screen sharing. And I'm putting the share screen on pause here so I can take a look here. Let me looks like I need to completely stop it. All right, here we go, resuming screen share. All right, I gave you this problem with a balloon here, and what we wanted to do here is to bring up our annotated version of this. So let's see if we can find that. Okay, so I put a couple of things together here. What I wanted you guys to realize was that this is an approximation. So what I said was that we can approximate the volume of the sphere if we take half of a balloon, if we take half of a sphere, so I made this into a complete sphere. The middle of it is about there, and I drew that across there. So I'm assuming that this is my half circle. Now they give us the diameter, so I put in here that the radius would be half of that. So I put in 50 divided by 2 is equal to 25. Then the other thing I needed was the height of the cone, and we're approximating that. And if we want to what I said was, okay, from here to here, let me just draw it in then. This is shapes. So if I go from here up, that would also be the radius. So this distance from the top to the bottom is 80 feet. If I take 80 feet minus 25 feet, I get 55 feet. So the volume is going to be based, the volume of the cone is going to be based on this height, which I calculated to be 55. So at this point, I'm going to simply start plugging into this equation. So I'm going to say that V is equal to 1 divided by 3 times, this is pi, and I'm going to use 3.14, and then we're going to have the radius of 25 squared. So let's see what we come up with if we, so if I do that, I get 1/3 times 3.14 times 25 squared equals 1. That's what I want to use. Times 55. Okay, let's try that. 1/3 times 3.14 times 25 squared times 55 equals, I get 35,000. Let's call it 36,000. And this is going to be feet cubed. All right, so that's the volume of the cone part of this. Now we want to do this half sphere up here. So we're going to come down here and say that the volume is equal to, and we know that it's 4/3 pi r cubed. So I'm going to go 4/3 times 3.14 times 25 to the third power. And what's that going to be? So we're going to have 4/3 times 3.14 times 25 x3 equals, now what I need to do is to remember that this is half the sphere. So I'm going to take 1/2 of that. That's going to be about 33,000. So the total volume will be equal to 36,000 plus 33,000 or 69. All right. So just to, I remember this is an approximation and we're talking about volume of hot air. So it's not going to be a precise science. So what we're doing is approximating this with a hemisphere and a cone. And we came up with the radius to be 25. And we came up with the height of the cone to be 55. And it's 80 minus the radius, which turned out to be 55. Now is when I can take this and just plug it in. So I like people to do a little bit of thinking before they just plug into formulas. So now that I've done this, I just take the formula 1/3. I'm using 3.14 for pi. Radius is 25, and I'm squaring it, and I'm multiplying by the height. So I get approximately 36,000 cubic feet. Now I want to work with the sphere. Now, remembering that I'm only dealing with half. Which means that I have to remember that I'm going to take this answer and divide it by 2. So now I'm plugging into the formula. I'm going to take 4/3 times pi, 3.14, and now I'm going to cube this. So when I do that, I get this number, 65,416. Now I'm going to take half of it, and I come up with 33,000 cubic feet. I add those two together, and I come up with this answer. So that's what I got. And I just thought that was an interesting problem. So hopefully you did too. So let's move on to the next thing. Let me just get rid of all this stuff. And we'll stop the screen share, and then we'll end the lesson.